My name is Fadhlan Harashta, and this is my uh, assignment presentation for my Pubmed assignment for machine learning. So let's start this video. So first, we want to get all the library we needed. So we have pandas for data manipulation. We have matplotlib for plotting the visualization. We have seaborn also for plotting the visualization. We have numpy for all the mathematical and vector operation. We have string. We have sklearn. We have counter for counting. Then we have array. So first we need to get the data set. In order to get the data set, uh, first uh, this is where we get the data set. So first, since we need to, it's about cancer. I choose pancreas cancer. The first thing to do is change this to 1 year, and then put the text available to abstract. Click save. Change it to our result, and change it to Pubmed, and then we create file, and then we will get a txt file. This one, as you can see, it's very, there's a paragraph, there's code, there is date. It's very chaotic. So the first thing we need to do is to uh, clean the data. So after we input the data using this command, uh, we declare it as content. We find all words starting from A, B, and ends before the next line. And then next uh, is we want to use regex to abstract all the text, and then we clean it by joining the all abstract, and then we remove a new lines, digit, and punctuation, and then we convert all these uh, words into lowercase. And then next we use count uh, to get all the number of each word. And so here we get the result. Next, we visualize it. As you can see here, pancreatic has the highest number of frequency, and there is patient, there's cancer, there's CI, and etc. etc. And since we want to send it to AI, we uh, convert it into a CSV file using this command. So let's start with ChatGPT analysis. So first, we use network as to create a network. Uh, we also use sklearn and combination. So the first thing to do is we create a Word document matrix for only the top words, and then we compute the cosine similarity between each pair. Next, we build the similarity based network graph and then we add edges between words if the similarity is above 0.1. So this is a threshold. And then we plot it, and this is the result. As we can see, it's very chaotic, and it's very it doesn't look very accurate. That's why we changed to a new one. We're using Grok. So Grok also use request and zip file and IO. So first we uh, read the CSV one before. This is CSV file. Uh, this is only to make the word in lowercase. Uh, and then we want to create a category for each words on the dataset. There is clinical, there's oncology, there's research, there's yeah, and etc. Uh, and then we create a graph and then we add nodes. So we initialize a new graph and then we add nodes for each of the words. And then by using loop, we create edges between words that belongs to the same category. And then we plot it. This is the result from our plotting process. As we can see, it is a lot more understandable than it is easier to understand than ChatGPT because as we can see, we know how frequent they are by the size of the circle. We know the connection between them with uh, the the line, and we know the category of each of them uh, from their location. But while this is a great thing, we want to get an easier way to understand it. That's why we use DeepSeek. In this case, we only add a linear segment color map and name color both in Matplotlib because we want to use color in uh, the graph. So first is pretty much the same. We create a graph and then we read the CSV file, and then uh, for we want to create co-occurrence edges for visualization. So we simulate edges between meaningful words pair, for example, between cancer and patient. So we the first thing to do is uh, we we simulate the edge here. So we can tell that if each word has a meaningful connection between them. So we also use categorization like just like before. So we categorize the pancreatic cancer patient tumor as the core term, and then we put treatment term as treatment. Sorry about that. Treatment, chemotherapy, surgery, therapy, etc. So there's research term, there's a prognosis term, this is also cell term, this is uh, yeah. So next we want to calculate the degree of centrality and prepare the color mapping before uh, based on how connected they are. Lastly, uh, lastly we do the plotting, and this is the result. As we can see, it is much more easier to understand, but at the same time, it is not as accurate as this one. What I mean is that uh, the thing is actually it's pretty accurate. So I don't know if you can see it clearly, but there is actually a line here. Uh, Actually, let me try to increase the line maybe to 10. Oh, sorry. I think I just gonna run all of the code again. So it might take a bit of time. But so since we have increased the width, but so on each nodes there should be I mean there is actually the yeah can you see that so there is a line here. So here we can see the connection between them, but well uh, it's pretty uh, transparent, but we can tell connection between them. I think I am. Can we change it to black? No. Uh, yeah. What? So we can tell there is connection. So there is no connection between here and here, between here and here, between here and here. There's no connection, but we can tell the connection in this area between each word. So in this word. So let's okay. Let's just talk about how the uh, the graph works. So the color explains how central they are. So since we are talking about pancreatic cancer, so it's of course cancer, pancreatic, and patient will be on the most central. So the further they are, the less central they are. And then the node size explain the frequency, and then this the edges explain the connection. So in my conclusion is that DeepSeek give us the best result for this visualization. We can tell uh, how central they are. We can tell if they are connected or not. We can tell if they are uh, if how frequent they are. So yeah, I think in this case, DeepSeek has the best value, and that is all I can present. Thank you for your attention.